About 15 years ago, I decided to be a carpenter. To get a job, you usually had to tell the boss that you knew how to do everything, but I didn't. I knew that I had to build a stairs sometime soon. I ended up building that set from a book I kept out in my pickup. The stairs worked out all right, but it sure took a lot longer than it should have. Since then, I've built a lot of stairs, and I've learned a little bit more on each one of them. Stair building is often thought of as a mysterious craft, but it really isn't, and there's no reason to have someone else build your stairs. I hope this tape and the book I've written help you out. Hi, I'm Scott Schuttner, and I'm a home builder and woodworker in Fairbanks, Alaska. And in this tape and book, I want to show you some techniques for building basic stairways. I'm in a friend's shop where I built some mock-ups of interior partition walls. I've used standard construction techniques such as 2x4 pre-cuts, double top plates, and I framed the stairwell with 2x10 floor joists and used 3/4 plywood for the subfloor. Our first stairway will be a straight run. It'll begin down here, ascend up this wall here like this, and butt into that header up there. I want you to pretend that we built a 2x4 partition wall here also, so that our stairway will actually be coming up between two partition walls. We've left this wall out so you can see the construction details better. On this other mock-up over here, I've used the same construction techniques such as pre-cut studs and 2x10s, but instead of a straight run, we're going to build an L-shaped stairway. It'll begin here, rise to a platform landing here, and have a short flight from the landing to the second story. This is a model of our first stairway, and it's a straight run, as I said before. It's typical of a stairway in modern construction in that we've used plywood for the risers and treads, and it'll eventually be covered with carpet. These three boards represent 2x12s and are called cut carriages, and they're notched to support our risers and our treads. This board over here is called a stringer or a skirt board, and we are going to butt our treads and risers into this board. There's also some other construction details, such as how we attach the carriages at the top and at the bottom, which I'll show you as we get to the full-scale stairway. When I first started building stairways, I spent a lot of time poring over books and charts trying to figure out how to cut these notches in the carriages. But after many years, I've realized that there's only one or two critical measurements we need in order to make all these calculations. The first and most important is the vertical distance from finished floor to finished floor, and this is known as the total rise. Our total rise measurement is 107.5 inches. It's also important to check to make sure that the spot where our stairs will end is level with the spot where we've taken our measurement. If not, you'll have to adjust for the difference. Now I'm using the same thickness carpet upstairs as I am downstairs, so I know my 107.5 inch measurement is a finished floor to finished floor distance. But finished floor materials are not the same on both floors all the time. For example, say we use 3/4 inch flooring upstairs, and this was a concrete slab downstairs. We'd have to add 3/4 of an inch to our measurement. If we had 3/4 of an inch oak downstairs and 1/2 inch finished flooring upstairs, we'd have to subtract 1/4 of an inch from our measurement. Now let's do some calculations. I've written down our 107.5 inch measurement here. I know that in a house with a 9-foot measurement from floor to floor, we'll normally have 14 risers. You'll note on our model that I start with a riser and end with a riser. So if I have 14 risers, I'll have 13 treads. I've divided our 107.5 inch measurement by the 14 risers and get 7.678 inches per rise, or 7 11/16. I know this is a comfortable rise, as we should fall somewhere between 7 and 8 inches. A rule of thumb says that the rise plus the run should be between 17 and 18 inches. Our rise of 7 and 11/16 inches, plus a run of 10 inches gives us a number which falls between those two. I've been talking about our rise and our run in terms of notches in this carriage. But if our risers are all the same thickness, our run of 10 inches should be the same when measured from the front of this riser to the front of this riser. In addition to this run of 10 inches, we have an overhang here called a nosing of 1 1/8 inches, which is measured from the front of this riser to the edge of this tread. So our run of 10 inches plus a nosing of 1 1/8 gives us a total tread width of 11 1/8 inches. That's how I calculate for a typical straight run of stairs. You can use these calculations for a short flight or an even longer flight of stairs, long as we stay within a comfortable rise and run. There's more about that in the book. Now, let's lay out some carriages. Finally, I get to use a real piece of wood. I've chosen a nice straight 2x12 that's relatively free of knots. This is a piece of Doug fir, which is one of the strongest framing lumbers we have available locally. Another reason for using a 2x12 is so that I can keep at least 3.5 inches between the point of our notch and the edge of our board. I've set these stair buttons for our calculated rise and run. These stair buttons are great because they'll keep all the triangles the same as I move down the board. If you don't have a set of stair buttons, you can use a 1x4 clamped to the back of your framing square, and that'll work just as well. Since our framing lumber has rounded edges, it's important that these lines intersect the correct point on our framing square, because even a 32nd of an inch error in each notch could equal a 1/2 inch error in the overall length. Now I'll lay out the rest of my notches. Before I show you how to mark the bottom and top of the carriage, let me show you a method that will reassure you that your layout has come out at the right length at the bottom. This method will also help you determine the length of lumber you'll need when buying your carriage material. Remember the old Pythagorean theorem, a squared plus b squared equals c squared? A is our total rise, measured from finished floor to finished floor. B is the total run. That's just the sum of our individual runs of our treads. C is the hypotenuse. This length will give us a way to check our layout from this point to this point. Knowing this length, I can buy my carriage lumber. I always like to buy a foot or so extra on each end in case I have to cut off any splits. Also knowing this length gives me another method for laying out my carriage. I can take this number, divide by 14, the number of my triangles, transfer that length to a pair of dividers, and lay out on the edge of my real 2x12 these points where the triangles intersect the edge of the board. You may have to adjust this dimension a couple times so that you come out at the right spot at the very end. Then I go back with my framing square and draw my lines through those points. This is the top of my carriage, and I've just drawn in the line that represents the finished floor, and the line that represents where the carriage will butt into the header. I need to subtract 3/4 of an inch for a hanger board, which will be the means of attaching our carriage to the header. Don't worry, I'll tell you more about the carriage board in a minute. Now I've got my saw lines marked at the top, and I can go finish laying out the bottom. This line I'm going to draw represents my finished floor. And this is an area where people commonly have a problem, and I certainly have had a few too, in that they don't do what is called dropping the carriage. This is a piece of plywood that's of the same thickness as I'm going to use for my treads, 1 1/8 inches. You can see when I position this, as if it were a real tread, that the distance from our finished floor line to the top of our tread is greater than our calculated rise. To solve this, I'm going to shorten the height of the first riser by removing the thickness of this tread from the